Welcome, everyone. One of the enigma that we face today is that we think we know more and more about space, more and more about sun, celestials, everything. But a fascinating part is we do not know enough about the Mother Earth itself. And as we start exploring more, how we find out more stuff about it. There's a combination of few people who are involved in this kind of exploration. And that has to do with um, astronomers, people who are studying the celestials, people who are studying, and then uh, bringing material from the space to analyze, and then people who are geologists who are studying the Earth itself, people who are oceanographers, people who are scientists, people who are chemists, biologists, every or for example, zoologist or botanist involved in study of their life, every single modality of science is involved to try to find out. For example, weather guys, meteorologists. We try to put everything together, and we still have not understood some of the things about this whole phenomenon called Mother Earth. And just to give us a small idea about it, only some portion, a very small portion of the crust is what we know about. As soon as you go below the crust and goes into different layers, we start losing knowledge. And to the journey to the center of the earth, nobody's gone there anyway. So there's so many things about that we do not know, and yet life exists on it. So this whole process evolves around recognition. And when we do the moon salutation, sun salutation, moon salutation, and earth salutation, in reality, a little bit more is known about the sun. Some is now being known about the moon. Earth, we're still wondering, and that there are reasons for that. For example, I'll give you some examples of it, and so then we'll do the practice part of it. And the practices that we plan to do are associated with this whole idea about the history and the evolution of how the universe came about. And mysteries of the universe are very fascinating. For example, the universe, the solar system that we know about, arose about 4.75 billion years ago. And that time it was basically a hydrogen mass. And then the hydrogen got converted to helium from 1 to 2. I'm just wondering if that was the duality system starting then. Helium is 2, you see. I'm just thinking out loud. Now, then we go to the next step. We go from the sun, we go to the formation of the earth. Obviously, these masses of gases, and they were all in the universe, and they were colliding because of the gravity. Gravity pulls each other. And gravity is because of the mass, and because of the pull that exists, bigger the mass, bigger the pull. And when that happens, meteors and meteorites and all this stuff that are just basically, they are big gaseous masses, they collide. And when they collide, some section separates out, or it separates out because of the fast rotation, whatever that. And why do they rotate? Because of the gravity. It's interesting how if you go out in space, they say there's no gravity. However, it does rotate, and it just causes that phenomenon to occur. And so the Earth was born 4.57. Now they're talking about 4.57 billion years ago. And Earth, as the Earth was born, the Earth was moving fast at that time. Very fast rotation. When first is born, it's just still revolving very fast. And Moon apparently was born about 4.5 billion years ago. And that happened to be because it says that there was a huge meteorite of the size of the Mars, for example, Mars that came and hit the Earth. And when that happened, they initially combined or something. That they're not sure about exactly how that happened. But they combined, and then just exactly amount of a material from the moon got separated, and that got separated in such a way that it went out, but it remained in the orbit. The gravitational pull of the Earth and the moon was such that they were balanced. This is the beauty of how the thing came about, and that's why Earth was straight like this, moving around. It got tilted. Initial day, for example, the sun rotated about 28, 29 days it took to rotate on its own axis, revolve around that point. And that's still the same. It's remained about the same ever since the beginning. But what has happened is that that's also slowing down according to the scientists. But then about at that time the day was about 4 hours. The Earth rotated in 4 hours. It was fast. But then 3.5 billion years ago, you take about a billion years off, and 3.5 billion years ago, it started slowing down. And it started slowing down maybe because cooling down, whatever the issue was, it started cooling down. And very likely there was the water was brought onto the Earth. How? Because some of the outside material in the space, some of these meteorites started condensing earlier, cooling down earlier. They maybe formed the hydrogen, plus they formed ice or water, oxygen, whatever the phenomenon. Water started coming down and maybe came down from outside. That's one of the theories. But then 3.5 billion years ago, there was first evidence of life. They call it prokaryocytes. It's the one that the cells, there's one cell and a nucleus, but there's not much of nucleus. There's no nucleus, as you know, the center portion. That does not have a wall. They're called prokaryocytes. That's the first one, and at that time the day was 12 hours. It's a 12-hour day. And then the next stage we get is 2.5 to 1.7 billion. And at that time, photosynthesis started. And why is that? Because very likely water was still there on the Earth, and the sun rays were filtered in a way the atmosphere was forming. And so it was probably a proper combination of water, temperature, and heat, whatever that was, proper combination. And the photosynthesis started. That was about, in that time, the day was 18 hours. So now the Earth is slowing down. Just remember, Earth is slowing down. The next stage we get, and that time 1.7 billion years ago, that time eukaryocytes occur. Prokaryocytes and eukaryocytes are the ones with the cell in the center of the nucleus. There's a little membrane. It's like nucleus is formed. The prokaryocytes form the bacteria, the way we know it, bacteria and all. They started forming bacteria. Eukaryocytes are the one that started dividing more and form multicellular organisms, more cellulars. And that took 1.2, take half a billion years off, 1.2 billion years, and then multicellular organisms started. And that time, 23 hours. The day was 23 hours. Jump down to 400 million years, and the first human life appeared. That is when we arrived at 24-hour cycle. And obviously we have seen about tilting and all. One more item that I want to mention about how do we find all this out? And it's very fascinating to see how they really determine the age. It is said that the age is written in stone. And it's not funny, but stone is how we, the geologist, when you go to the Shone Osher, you see rocks, everything. These are the ones that the chemicals analysis is what happens. And so one element that fascinating to learn about is called zirconium. Zirconium is the very initial element, and it's one of the very old, billions of years age, zirconium. And zirconium then forms another chemical, another element called uranium. Zirconium gets into the uranium, and there's a timeline for that. And uranium is the one which starts having, the uranium has a radioactivity. And the radioactivity is started here, for example, and started decaying. So there's a little curve that says, okay, this is so much radioactivity, and then it goes down and all that. So that radioactive curve, and then gets converted into one very well-known element called lead, from uranium to lead. And what happens is that there's only certain things. Uranium can get into lead, zirconium cannot get into lead. Now, if you take a rock and see what is the amount of zirconium, what is the amount of lead, and what is the amount of decay of the uranium radioactivity, now you're able to establish a timeline. And so whenever we see, well, what's the moon rock and what's got to do with that? We talk about Earth analysis and all this stuff. Why these are so crucial? Oh, we've got some samples of rock from the moon. I mean, I always wondered about it. What the heck does that mean? What's the importance of that? The importance of that is this, very fascinating. Earth, after it's formed with the atmosphere and everything else, started underwent changes because of earthquakes, because of many things that happened. So the crust and everything started getting disturbed. So you have earthquakes, volcanoes, things like that nature, because it's not stable. It was not stable. And not too many meteorites have hit Earth as much. Interestingly, moon is pristine. It's not hit by anything. There's not much of earthquake, not much of other things going on. So moon rocks represent a lot more of time lining. And so we learn a lot more about Earth from moon. Think about that. So these are the simplified facts, and then we say this. Okay, this is the whole origin, how the origin became, and what it happened. And so our whole approach towards understanding Earth, and this is just the beginning. This is the only beginning, and we're going to do more journey about this, and we're going to work a little bit more on what Earth salutation really means to us in the practices.